Hello friends, this is Rakhi Kaushik and today we'll be doing electrolysis of aluminium and brine. Let's start. Let's start with the electrolysis of aluminium from bauxite. Bauxite is an ore of aluminium and will follow the Hall-Héroult process. Generally, elements like aluminium are very reactive and they have a great affinity to the oxygen. So we do electrolysis to extract them. Now alumina, that is Al2O3, pure alumina will take, let's start with the experimental setup. So we take a steel tank in that we'll do a carbon lining. This carbon lining will join to the negative terminal and will act like a cathode. In this, we'll put an electrolyte and carbon rods that will act like a anode. Okay, anode and cathode both are made up of graphite. And here we'll have a control lamp. So it's a charge control lamp and a key and the battery. So the one which is joined to the negative terminal is cathode and the one which is joined to the positive terminal is anode. So both cathode and anode are made up of graphite, that is carbon. The electrolyte that we take here is the fused alumina, that is the ore, Al2O3, and cryolite, it's another ore of aluminium, that is Na3Al(F6), and fluorspar, that is CaF2, in the ratio 1:3:1 by weight. Actually, the melting point of aluminium is very high. It's around 2050 degrees centigrade. So it wastes a lot of energy to reach that temperature to do the electrolysis. So what we do is we add cryolite and fluorspar. The purpose of adding this is it lowers down the fusion point of the mixture to 950 degrees centigrade, which saves a lot of energy. And it increases the conductivity and it acts like a solvent also. So because of these three main uses, we add cryolite and fluorspar to the ore of aluminium. Aluminium, that is pure alumina. And we also sprinkle a coke. So a powder coke is sprinkled over the electrolytic mixture which is undergoing electrolytic reduction. This helps in, this prevents actually the burning of carbon rod in the air. And it also prevents the heat loss by the radiation. And this process of electrolysis is a continuous process. So once alumina get finished, we keep on adding the alumina, and even the graphite rod also become thinner and thinner. And when we find that they are very thin, we replace them periodically. The aluminium produced by this method is 99.5% pure. So let's see what happened. So what happened actually is we have a cryolite, that is Na3Al(F6), which will ionize to aluminium, sodium, aluminium, and fluoride. And fluorspar, it also splits up into calcium ion and fluoride ion. And our alumina ore, pure alumina, that is Al2O3, which gives aluminium ion and oxygen ion. Now we have sodium, aluminium, calcium and aluminium ions. Sodium, calcium and aluminium ions. All these three, they move to cathode, but only aluminium get discharged. Why? Because aluminium is below in the reactivity series. So since it is less reactive than aluminium, so it will gain electron, it will get reduced to aluminium metal. And this aluminium metal, since it's heavy, so we get a separate layer below at the bottom of pure aluminium metal. So I'm making all this layer, a separate layer of aluminium metal because it is heavy, and we can put a tap here and we can remove aluminium. So what we get here is aluminium metal, 99.5% aluminium metal. Now at anode, this oxide ion will get oxidized to, will lose electron, get oxidized to oxygen. It will oxidize to oxygen gas. This oxygen gas, when it moves up, it reacts with these electrodes, these anode, carbon anode or graphite anode, and it reacts with this anode to make carbon monoxide and carbon dioxide. Carbon monoxide and carbon dioxide. So if they ask you what is released at anode, it is actually carbon monoxide, carbon dioxide and oxygen gas. And what we get at cathode, it is aluminium, which settles at the bottom being heavy, and we can remove it, which is 99.5% pure. So this is the extraction of aluminium by Hall-Héroult process. Now let's see brine. Electrolysis of brine. Brine actually is a concentrated NaCl. It's a chlor-alkali industry because it releases 3 very important products. It's a full industry and concentrated NaCl. It is actually salt water. So we have a separate membrane cell for the electrolysis of concentrated brine, where we use a selective ion exchange membrane. It's a inlet, then we have one chamber, then we have other chamber. It's a rough diagram I'm drawing. Now both these are separated by ion exchange membrane. Now this membrane is selective. It only allows sodium and water to pass through it and no other ion. So it only allows sodium and water, that is H plus and OH minus ion, to pass through it, nothing else. Now anode is made up of titanium because titanium is less reactive. Anode, that is the positive electrode, and cathode is made up of nickel. So cathode, that is the negative terminal. Cathode, it is made up of nickel. So cathode is made up of nickel and anode is made up of titanium. Now what happened? We pass brine from here. Again, I'm telling you, brine is the concentrated NaCl. It's a salt water. So what happened is, when we put brine from here, now brine is NaCl, so we have Na plus ion and Cl negative ion, and since it has water, so we have H plus ion and we have OH negative ions. Now what will happen when we put brine from here? This Na plus ion and H plus and OH ion can move through the membrane by the pressure, and we have H plus and Na plus and OH ion in this chamber. So what is left here is the chlorine. Now what will happen? This chlorine at anode will oxidize and will change into chlorine gas, which can escape out. So we can see chlorine gas coming out from here. So what will happen at anode? Chlorine, that is chloride ion, will lose electron and will change into chlorine gas. Chlorine is a pale greenish gas. So you can see a pale greenish gas coming out from this chamber. Now what will happen in the other chamber is Na plus H plus and OH negative goes. Now H plus sign, since among Na and H plus is below in the reactivity series. So at cathode, H plus ion will get reduced by gaining 2 electron and makes hydrogen gas. And hydrogen gas is released at cathode. So we can see the bubble of a gas that burns with the pop sound coming out from the other chamber. Now what is left in here is the Na plus ion and OH ion in the solution. Now Na plus and OH ion make this solution alkaline, make it an alkaline. So what we get here is NaOH. What we get here is NaOH. We can test by the indicator. It's an alkali. And we call this as a chlor-alkali industry because we get three very important products from here, where chlorine, which acts as a bleach and is used to clean swimming pool, hydrogen is used to make margarine, and NaOH is used to make soaps, and so many other uses. So it's a whole chlor-alkali industry where we do electrolysis of brine to get three very important products, that is NaOH, an alkali, H2 and Cl2. I hope this session helped you. Thank you so much for watching and have a nice day.